Hello, AP Stats. This is Mr. Kim, and this is the video for Chapter 10 and 11 review. I'm going to go through questions from 1 through 39. That's the first about 7-8 pages of this entire packet. I know that this is a long chapter, but when you take a look at just the questions and how they're formulated, they're actually really not that bad. They ask you a lot of like confidence interval questions and T-interval tests. And I guess the main difference of the thing that you have to really figure out is what is the difference between Z and a T-test. And you'll see the difference as you go by which one you're actually supposed to be using. And so without further ado, let's get started. And please have your calculator on your side. There's a lot of calculator questions here that I need you to be aware of. So I'm just going to pull that up on the side here. So on the calculator, so I can just kind of use up for the inverse T and those kind of things to kind of help me get through most of these questions for those type of contexts there. Number one, which of the following would tend to decrease the width of a confidence interval, it says. If you remember back from chapter 8, a confidence interval basically is sort of like, think of it as like a spread. And what I always like to think of it as a spread always decrease, or it gets narrower when the sample size increases. It just makes the sample better just because you're taking much more samples. Your variability goes downwards, which means if I actually want to decrease the width, I have to increase the sample size. So that's definitely a check. Obviously, the width of a confidence interval is directly impacted by the confidence level itself. So using a higher one will increase it. 99% is wider than 95% will ever be. So it's going to be 1 and 2 only, D. Number two, each individual in a random sample of 50 internet users was asked how many minutes he or she spends online in a typical day. We use 99% confidence interval and we get that. So they are asking you which of the following is the correct interpretation. I think it goes on without saying that you can also, we always start with like 99% confident that all internet users, the mean number of minutes spent online, typical days between 80 to 200. That is the format that we always want to go by. And checking my answer, yes, 2 is definitely going to be C for this one. Number 3, this one, if we're following, which of the following confidence intervals should use to estimate the mean number of miles traveled by all visitors? Now, first of all, if we are actually using the 200 visitors to a national park, we'll select at random. And maybe the biggest obstacle here is how do you know when to use, let's say, a Z-score versus a T critical value here? The main difference is, first of all, let's get rid of E because we're not talking about proportions. We're talking about estimating the mean number of miles. So if we're asked to estimate the mean, we can't actually, we don't know what the parameter is. We don't know what the true mean of all the 100 visitors, 200 visitors, or even all the visitors to a national park would be. So C and B are eliminated. So we know for a fact that it's going to be between A and D. And between these two, if we're using the samples to estimate our means, we definitely want to be using a T-test. So number 3 would be A because of that reason. Or you can just kind of think of it as using the T critical value for this type of sample here. But I think the best way to eliminate is first to eliminate E, then B and C, because we're not talking about the parameters. We're talking about the sample X. And then we can't use Z because we do not know what a parameter is here, or nor do we know what the actual standard deviation of the entire population here. It gives you a parameter for this one. Remember, the main difference between a Z versus T-test is a T-test, you do not know the parameters, mu or standard deviation, they're not given, but for Z-test, they will be, or they will be suggested in such a way that it's going to be the population mean or the population standard deviation. Suppose you take a simple random sample. This is unknown, so you know that you're supposed to be using a T-test. Your sample size is 10. Which of the following should be used to find a 90% confidence interval? Now, you need to use your calculator for this. If it's a 90% confidence interval, which means you're 90% in the middle, you need to find out what this value is. That's your T value. That's your T star. In order for me to figure this value out, you need to count from the left, which includes this extra 5%. Why is this 5%? Well, because that's 5% left over on the other side. So 5 plus 90 plus 5 gives you back up to full 100% like this. So we want to actually put in 95% into our inverse t. So we're going to go to our calculator, second var's inverse t, 0.95, and then the degrees of freedom here would be 9 because our sample size is 10. Remember, degrees of freedom is always n minus 1 for this one. And then we press paste, and voila, we have our t value of 1.83. That allows us to eliminate all the choices without 1.833. And the difference between these two is that, again, we are not given the standard deviation. It straight up says that the sigma is unknown in the context of the question. So therefore, the correct answer here will be C, and 4 is indeed C, right, on the answer key. Number 5, a large sample, n is 250 was used to compute this. So this is your confidence interval. And it says that with this interval is equivalent to A, one of these following things. So if I have well, first of all, there's something that's actually missing here. It's the t value. And it turns out that the t value here, since there is nothing said, we can assume that the t value is going to be 1. So what you can do actually is you can use all of these answer choices and figure out which one actually gives you t value of 1 when you actually use inverse t. So this is an inverse t problem. So we're going to go to our calculator. And let's say that we check to see if answer choice A was correct. If 50% was in the middle, that leaves us with 25 and 25 on either end. So we can use inverse t, 0.75, and degrees of freedom here, you might have guessed it, it's 249 because it's 1 less than 250. Press paste. Now that gives me about 0.67, not so close to being 1, so A is out. We're going to do the same thing, but in this case, if it's 68% in the middle, that leaves us with 32% left over from the both. And so that will be 16 here, and then that will be 16 here. So in total, that will be 0.84%. And it looks like that's the closest one we're going to get to being actually a t value of 1. So the correct answer is B, and therefore number 5 is B. Okay. The only reason why B is the answer, like I said before, is that because t is equal to 1. Notice how there's nothing given to you in the problem. So t is just going to equal 1 times s over square root of n. Which of the following is certain to reduce the width of a confidence interval? Pretty much the same question as number 1 here. To reduce the width of the confidence interval, remember that we need to increase our sample size. And our confidence interval has to go down because to reduce the width. So it's definitely B for this one. 7, what is the difference between t interval and z interval? Z intervals are used if you know the population standard deviation, and t intervals are used when you do not know population standard deviation. Honestly, this is the main difference between the two. Z interval is when the population standard deviation sigma is known, and this is when sigma is not known. So that is the main difference. T intervals are used when you know the population standard deviation, completely opposite of what you're trying to say. And C, D, and E are just not really relevant. It's T intervals use the sample size, where it's Z intervals. Z intervals don't even bother with the degrees of freedom, and you can see why the rest of them just doesn't make any sense. And so the best answer here is A. Number 8, we have selected a random sample of 18, mean, and the standard deviation is given to us. 98% confidence interval means that the inverse T has to be 0.99. Remember, that's 98% in the middle, 1% on either end. So that will leave me 0.99 with the degrees of freedom of 17. So let's type that in and see which of the following answer choices I can eliminate right out of the gate. So that's inverse norm. So inverse T of area of 0.99 and degrees of freedom of 17. It's 2.566, which means I am down to D and E. Now, the main difference is it's the square root of n for the formula. So we are just going to plug in sample size of 18 into the equation here. So the correct answer here would be D. Number 9, the average number of minor medical needs at Army Hospital in Iraq over 49-day period was found to be 11.2 with a standard deviation of 3.6. With what degree of confidence can we say that the minor medical needs at the Army Hospital per day is between 10.3 and 12.1? So if it's between 10.3 and 12.1, first of all, let's look for what we call margin of error. The margin of error is this. This is your critical value, or I'm sorry, this is your critical value, and the mean of X, the sample mean, that is just like the middle value of those two margin of error values there, if you add and subtract. So this entire thing will be what we call margin of error, how much you're going up or below the sample mean. And if I were to just write that down, and we have our, I believe, 49-day period was found to be 11.2 with a standard deviation 3.6. So we want to find out this value, the margin of error, from 11.2 to go from that to 12.1. It seems like you added 0.9. To go from 11.2 to 10.3, we subtracted by 0.9. So our margin of error actually equals 0.9 basically. Okay, so then afterwards, what do we do after? What do we plug in next? Well, it seems like we are given the standard deviation, so we're going to plug that in 3.6, and the sample size here is a 49-day period, so square root of 49 equals 0.9. And then when you actually solve for the t value here, that's 7, so 0.9 times 7, that's 6.3 divided by 3.6. So I get my t value to be somewhere around 1.75. Now, what is our next job? You're going to use your answer choices to your advantage once again. And I'm going to start from 80. We're going to use inverse t. And then if it's 80%, we need to understand that we're not putting in area as 0.8. Rather, it's 80% in the middle. Then that's 10%, 10% on either end. That's 0.90 with degrees of freedom of 48. Paste. And it gives me about 1.299. Remember, you want to have the answer choice to give you about 1.75 or close to being 1.75. So I'm going to go back up here. Remember, if it's 85% in the middle, that leaves me with 15 on either end, 7.5. So that's 0.925, comma 48. 1.46, still not good enough. Let me go up here and then just type in 95%. Okay, so that's closest to being 1.75, but let's see if 95% is better. So it's 95% means 0.975. Okay, and then actually like that goes well beyond 2. So the correct answer here, the closest one that you're going to get for this is C. So you keep on using your answer choices, plug in your area with the degrees of freedom, and get the t value that's closest to being 1.75, and that should be the answer here. And number 9 is indeed C. Number 10, what assumptions are necessary for a 95% t interval with a sample size of 9? The sample was selected randomly from the population of interest. First of all, randomness has got to be part of your condition. The population standard deviation is known. That's not necessary for a t interval test. Population standard deviation should be unknown. The samples can be shown to be approximately normal with no skewness. Yes, normality has to be part of it. So 10 is definitely D. 11, a 98% confidence interval for a population mean is to be found to be this. Which of the following is a correct interpretation? Now, we might be saying that, we are 98% confident, blah, blah, blah. But if you take a look at your answer choices, it does not start with the typical, we are 98% confident. So we are not going to be looking for those rather than, okay, so then what should we be looking for? First of all, we always want to eliminate the one that says we have a 98% probability. A confidence interval has nothing to do with the probability. It just means that, it's likely that you're confident that certain things will happen. It doesn't mean that the probability of some things will happen in that manner. So the true mean is contained within the interval, that the sample mean is contained in this interval, that another interval will give a true mean of 127. Regardless of what the second half of the sentence says, we're going to eliminate A, B, and C like that. Or better yet, you can just kind of read this over and see how this really doesn't feel right or doesn't sound about right. 90% probability the true mean is contained within this interval. You might be pondering about A. So, but B and C are definitely not going to be right. I mean, another interval will give a true mean of 127, a very bold statement, but you're guaranteeing that it will give. You never want to say that in terms of the statistical answers. There is a 98% probability that the sample mean is contained within this interval. We always want to say the true population mean will be within the interval. If 100 samples of the same size are taken again, about 98 of them will contain the true mean value. If 100 samples of the same size are taken again. So basically you'll be down to A and D. And whenever you're faced with these types of situations, I kind of told you to kind of half jokingly to pick the longer one. And yes, 11 is D. The reason why 11 is D is because rather than saying in the terms of probability, you actually do want to say like, if you take 100 of them, about 98 of them, not exactly 98. This is A is just a bold statement. They're saying there is 98% probability, period. Like there is going to be a 98% probability that this will happen. This is saying, about 98 of them, will contain true mean value. So D is a very much of a better choice if you were to ask me. 12, when the sample size is increased, guys, I told you this, when sample size increase, it decreases the confidence interval. It will have no effect, double, cut the interval. It will make it wider. It will make the interval narrower. So 12 is B. Okay, so we have this, and this. Seems like we can eliminate C and D because the sample size is not fit in there. We are talking about a 95% confidence interval, means that 95% is in the middle and 2.5% here. So it seems like we just have to simply do the inverse T with a 0.975 with the degrees of freedom of 11 gas mileage values. So it will be 10. And notice how we get 2.28. So that will be the correct answer. So 13 should be A for that matter, for that reason. Number 14, a random sample has been taken from a population. A statistician using the sample needs to decide whether to construct a 90% or 95%. How will these intervals differ? The 90% confidence interval will not be as wide. That is definitely true. 90% confidence interval, okay, so that's completely the opposite. Which interval is wider will depend on how large the sample is. Wider would depend on whether the sample is unbiased, whether a Z statistic or T statistic is used. First of all, I think the 14 here, yes, it's A. 14 is just, the A is just such an obvious statement that even if you have no clue what's going on in C, D, and E, A is the best choice here. Will depend on how large the sample is. Yes, that's certainly true, but it's also impacted by the confidence interval as well as, I believe those two are the only things that affect it at the moment. But the sample size, yes, but it says that the random sample has been taken from a population. So it's the same using this sample. So we have the same sample for both, it seems like. Will depend on whether the sample is unbiased. Well, if it's unbiased, we're going to create the same type of, we're dealing with the same sample anyhow. So regardless, if I have a longer confidence interval, it means that I have a higher confidence level in terms of percentage. Will depend on whether it's a Z or a T statistic is used. It depends also because, you never can guarantee that for sure. Which interval will wider will depend on whether a Z or T statistic is used. Just because you use Z doesn't mean that it's always going to be wider and vice versa. So it's just going to be A. 15, a quality control inspector must verify whether a machine packs working correctly, standard deviation, mean, and a margin of error. So minimum sample size. Okay, guys, remember the margin of error is always T times the sample standard deviation over square root of N. So it's no more than 0.12. So I'm going to just set it equal to 0.12. Sample standard deviation is given to us. And the sample size is the one that we actually have to look for. It says that I have a 99.6 confidence. So which means I'm going to have to plug in, not p-value, 0.996 for the area. Oh, I'm sorry, 0.998 for the area. 99.6%, that's 0.2 here and there, which means if I add all these up, that would give me 99.8. So let's go to our calculator. So inverse T, 0.998 degrees of freedom. The sample size is actually the one that really bothers me because they don't actually tell you that, right? So you actually have to go through painstakingly, go through each and every single one of these choices and figure it out. So I'm going to plug in 7 for A because the sample size we're assuming is 8. And it seems like I get a T value of 4.2. So if I take 4.2 times the standard deviation of 0.3 and divide by the sample size that we've already stated as 8, do we get the value that we want? 0.12, it does not. It's 0.44. So I eliminate that. Let's do the same thing, inverse T, but now it's 15, your next answer choice. So the degrees of freedom will be 14. I'm just going to type that in, copy and paste that. 0.36, close, but not close enough. Next one on the list, we're going to use 24. Multiply that by 3. Multiply that by 0.3 divided by square root of 8. 0.33, still no good. So let's do 52. Hopefully this one is going to be worth it. 51 times, should clear this, type this in, and I get 0.319. Am I missing something here? We get t value divided by, oh, I'm sorry, I messed up the whole thing. That makes a lot of sense. So once I have this, I need to multiply by 0.3 and divide by the square root of the sample size, which keeps on switching on me. That's 0.266, so which is still no good. And I am going to take the one for answer choice C, multiply by 3 square divided by square root of 25. It's 1.90, okay? And then we're gonna take the next one here, which is inverse t of 51. That times 3 divided by square root of 52. Oh, look at that. That's wonderful. So that gives me 1.254, closest to being about, oh, am I missing something? Oh, is it more than 0.2 ounces? So I take my t value, I multiply. Oh, I'm sorry. I kept on forgetting the fact that this is supposed to be 0.3. All right, so it's 0.3 divided by square root of. Ooh. This is just annoying me. All right, so here we are going to take this answer choice times 0.3, not just regular 3, my bad. And that's divided by 25. So that just simply gives 0.190. And obviously, you guys can see where I'm going with this. If I do the same thing here, but if I insert point, and so it will give me 0.1254. So the correct answer here would be D, because you can see how the margin of error matches when I solve for that using that sample size, 52. All right, 16, an engineer for the Allied Steel Company. Using random sample of 15, the actual population is not known to be normal, but a graphic displays of engineer sample results indicate that the assumption of normality is not unreasonable. Okay, so they're saying that it's going to be normal. The process is newly developed and there are no historical data on the variability. A primary reason to use T instead of Z. Guys, go back up to this question where they actually tell you when to use Z and when to use T. Question number 7. Z intervals are used if you know the population standard deviation, and T intervals are used when you do not know the population standard deviation. So if I go down here, we're actually looking for anything that deals with standard deviations being known or unknown. Is estimating the population mean using the sample mean? To use a T confidence interval, you're never going to be, well, you're estimating the population mean. The primary reason the engineer should use T confidence interval though, it's because, well, what's the reason why the Z confidence interval couldn't be used? Well, that's because your standard deviation is not known, the population standard deviation to be exact. Is using a sample variance as an estimate of the population variance. It's B. Variance, remember, is very connected to the standard deviation. Variance is always standard deviation squared. And because it's not given to us, we are estimating also the population variance using a sample variance, which is not something that you should be doing. We don't have any other choice though. We are only given the sample and we can base off of the sample standard deviation. But if you do that, you're required to use a t-test by definition, okay? All the other ones using a data from specific day has a small sample. Z confidence interval should never be used with a small sample. That is true because we only have a sample size of 15. And remember that the central limit theorem for the Z test says that the N has to be greater than or equal to 30. So E is sort of also making sense, but the main reason as to why you want to use T is because some of the parameters are not known. That is the one definition you want to state for question like 16. All right, number 17, we have a confidence interval. Based on 50 students, 90% confidence interval has been provided for us. Which of the following statement is true? Again, we don't have like the we are 90% blah, blah, blah. 90% of the time. Again, we do not want to say the probability of something that's happening here. 90% of all students spend between on lunch at the school. Very straightforward statement, no cushioning words whatsoever. B would be the worst answer possible. 90% of all random samples of 50 students obtained at the school would result in a sample mean amount of money students spend on lunch between 3.45 and 4.15. Sounds about nice. D says 90% of all random samples, 50 students, same thing, result in a 90% confidence interval that contain the true mean about the money students spend on lunch. So C and D is pretty much the same thing, but with 90% of all random samples of 50 students obtained at this high school will result in 90% confidence interval that contain the true mean amount of money students spend on lunch. I know the answer says D for number 17, and this is one of those questions where I just can't really explain to you. Number 17 is something that I would just get it wrong. I would honestly be able to say, because the numbers are stated so nicely for C, I will be debating also for C. Approximately 45 of the 50 students in random sample will spend between 3.45 and 4.15 on lunch at this high school. That is fine. Also, it's just that we have 90%, it's talking about the probability once again. So approximately, nice cushioning words, 90% of 50 is indeed 45. Approximately about that much in the random sample will spend between 3.45 to 4.15. Honestly, C, D, E all sounds good to me. I'm not sure why D is the best answer, but for this one, I'm just gonna leave it up in the air. 17 is one thing I can't explain to you. 18, the National Honor Society at Central High School plans to sample a random sample of 100 seniors, 95% confidence, okay? Selecting sample, the National Honor Society decides that it wants to decrease the margin of error. Margin of error, remember, it's T times the sample standard deviation divided by square root of N. So if I want to decrease the margin of error, the only thing that you have to take into consideration are these three components. Using the sample, well, you are supposed to be using sample standard deviation, but you are supposed to really debate between D and E. If you increase the confidence level, your margin of error actually goes up because your spread is that much larger. Remember, we want to decrease the margin of error, which means we need to increase the sample size here, so it will narrow the gap and it will decrease the margin of error. Think of margin of error as like, if this is your sample mean, this distance from up and down, like this would be your max and this would be your min, your up and down, that will be your margin of error. So if I want to actually decrease it, you want to narrow that gap. So whatever narrows your interval will actually narrow your margin of error. So suppose we have two SRS. Okay, so that means that the two samples are independent. We measure the same variables for both samples. Suppose both populations of these values are normally distributed, but the means and standard deviations are unknown, which means we're supposed to be using for T. No Z, no least squares regression line at the moment. For purposes of comparing two means, what is the main difference between matched pairs and two sample? Matched pairs means that the samples, like one person is given two separate treatments, like 1 and 2. This says the samples are independent from one another, so we're going to say two sample T procedures for number 19. We have two separate samples. To use a two sample T procedure to perform a significance test, we assume that T test, no, A is the worst answer. Samples from each populations are independent. The distributions are exactly normal. You don't need to have that actually. You don't have to have a population that's exactly normal to actually perform this test. The sample sizes are large, not really, as long as the distribution has no skew or outliers. No skew, no outliers. That means that you can actually conduct the t-test. So the correct answer here, 20, should be B. 21. Okay, so we have one section receiving no assignments. The other one has received assignments. So this one, no assignments. This one did receive assignments. And then they compare their test scores or whatever. And it turns out that it's a negative value. And to be more specific, that's negative 5.3, negative 1.7. So what does that mean? It means that the value for the people the mean average value for the people who received the assignments was higher. Higher number, lower number. Lower number minus the higher number should always give you a negative number, right? So there is evidence that doing assignments improves the average grade since the difference in population mean is less than 0. A is a perfect statement to say. Read the rest of them. It makes absolutely no sense. There's little evidence. No, there's a strong evidence here. Let me read the rest actually. That doing assignments improves. No, that's completely not true. There's a complete, utterly obvious evidence here that it improves the grade, not little evidence. There's evidence that doing assignments improves the average grade since 95% confidence does not cover 0. Yes, but does not cover 0 means that it could also be positive. So no, I don't want to say it like that. Does not cover 0. There's evidence that doing assignments does not improve the average grade. That is also another way, another answer choice B answer. I don't want to say that. There's little evidence. Doing assignments does not. Okay. Like I said, all the rest of them just doesn't make any sense. A is the best answer here. What would the 95% confidence interval mean? So I am 95% confident the sample mean difference is between those two values. I am 95% confident the true mean difference listening to MP3 players. So A is the worst answer here. I'm 95% confident that the true proportional difference, proportional, there's no proportions, it's just mean. I know that 95 out of 100 times the mean difference in time is this. This is a very blatant statement. So I guess 22 is obviously B for this one. Yes. Again, pick the best one. There's really no other way to go on about it than to say, read over the answers. There's always going to be a one best answers out there possible. Number 23, we have American presidents, British prime ministers. We're comparing the age, I believe, when they were both elected into office. 95% confidence interval based on T distribution. This procedure is not appropriate in the context because the sample size does not have to be equal to perform T distribution. The entire population was measured in both cases, so the actual difference, right? You know how many American presidents and British prime ministers are out there. They're countable, so it's B. You don't need to estimate for anything. T interval test is used to estimate stuff, like because you can't literally physically take all the samples, or you can't take all the values in the population. Therefore, you do these tests, but there's no need for you to do that here. Elections to office take place at a different interval in two different countries. Place has nothing to do with this. Ages at the time are likely to be skewed or likely to have few outliers. Yes, that's true. So the assumption for this using confidence interval formula are not valid. Again, B is the best answer because this is not appropriate because even like doesn't matter if it's skewed and all these kinds of things. It's just irrelevant. You have the entire population. You don't need to be wondering about how the sample is going to be having these types of shapes, outliers. You have the population. So you can just figure out what the actual true mean is. 24, the manager of a large hotel. We have a null and alternative. Oh, type 2 error. I think this was also a review questions on your previous packet. So type 2 error means that we fail to reject, which means we do not hire additional staff when the wait time is actually greater than 3 minutes. So that should be the consequence. 24 should be A. This one again, which of the following is the correct interpretation of this p-value? Again, guys, it's when the null hypothesis is true. You always want to state that first. The probability of observing that same type of value as extreme is 0.03. So 25 is C. All of these three things will affect the power of the test. Sample size increases, then I believe that the power should also definitely increase. The significance level of the test increased and the power increases. The size of discrepancy between the actual value, if that also increases here, then I believe that the power should also increase as well. So that actually goes on with question number 27. We have the parameter value, the hypothesized value of 100. If I want to find out the power to be the lowest as possible, the discrepancy, the difference between the value that you're measuring to the null hypothesis value should be the smallest. So it's A. The difference between 101 and 100 is the smallest out of all of these guys. A psychologist runs a study and reports her results were statistically significant at 0.05, means that P is less than 0.05. It means that there was enough evidence to reject the null so that H of A was going to be the true one. When they say it's statistically significant, always think of, oh, that means that H of A, the alternative hypothesis is true, null is rejected. If you want to write that down, please go ahead. So the p-value calculated was smaller is the one you want to say for 28. Type 1 and type 2, I don't think I need to state this, is rejected when it should not have, is not rejected when it should have. So C and B should be the next two. 31, again, very easy. I don't want to go over this. It should be B. Average 69 is less than 69. And then we don't want to use sample, mean of X with the bar next to it, on top of it, I mean. The heights of males normally distributed, the average is of random size of 25 is 69.72. So that is 69.72. And the standard deviation of the sample is 4.15. The standard error of the sample mean, oh boy. The standard error of the sample mean would be when we have the t-value times the sample standard deviation with the square root of n. And we have the mean value of 69.72 plus and minus that value. Okay, it's normally distributed and the average height, and that should be 4.15. So let's first just plug it in. We have the sample standard deviation of 4.15 and the standard deviation of, I mean the sample size of 25 here. So if we plug those values in, and let's calculate what that is real quick. Divided by 5, and you get 0.83. Oh, this right here is the standard error. I'm sorry, I almost forgot. This is your margin of error. And this right here is going to be the standard error. It's the part without the t-value in it. So that's the answer here for question number 32. It was, wow, that was just really simple here. All right, next, the appropriate degrees of freedom, 100, so it should be 99, 1 minus that value. P-value of the one sample t-test. Okay, so that is when we actually have to do the t-test. So stat tests, we're going to do stats because it's given to us of all these wonderful things. First of all, our null hypothesis value is 7.5. Your standard deviation, 2. Mean is 7. And the size is 100. We want it to be two-sided. And when we press calculate, it gives me p-value of 0.0124, which means the p-value for this is somewhere between this to that, which is C. 34 is indeed C, yes. Okay, so a 95% confidence interval for the mean number of years has spent. All right, so we want to do a 0.975 t-value. So second Vers, inverse t, 0.975 with degrees of freedom of 99. Ooh. And let me just delete that, press enter. Seems like I have 1.984. So 1.984 times the standard deviation of 2 and a square root of 1 over square root of 100 times 2 divided by square root of 100. And you get 0.39684. So that should be C. So it's the mean value plus and minus t times the standard deviation over square root of n. That's what I essentially have just done. Just type in all of those values. And as you can see on the right-hand side, it's 0.396. So this value is just simply going to be 4, or 0.4 to be exact. So it should be C. 36, suppose the mean and the standard deviation we obtained of 25 postal workers rather than 100. So sample size went down. If the sample size goes down, what will happen to the p-value? Okay, so first you need to think of this in terms of the t-distribution curve. This is a two-sided test, right? And so let's think about what happens when you decrease the sample size here. Remember, the t-value is always calculated by the following. It's the mean of x minus the parameter value stated over Sx, which is the sample standard deviation divided by square root of n. Now, if you actually decrease the sample size, your sample standard deviation will actually tend to go up because it's the denominator number of the denominator itself. So if that goes down, then the overall value of this goes up, which makes t-value to actually go down. So in that case, what would happen is, I'm sorry, wait a minute. So if t-value goes down, that means the overall value of this would go up. That means that the t-value should overall instead go down like this. 36, I believe I said was A before. Let's see. So if our sample size gets of 25 workers rather than 100, the t-value is always stated by the degrees of freedom with the area. Okay, so first, let me show you guys how to, let's say, calculate this from inverse t perspective. Let's say that we have the mean that and the standard deviation we obtained were the same. Okay. So let's say I actually plug this in. So 100 is your sample sample size over 2. The mean value that we have found was 7, and then we subtract that from the actual mean value, which is 7.5. So that will give me negative 0.5 over 1 over 5, gives me negative 0.25 overall. So that will be sort of like the t value that I should be getting. But if I were to decrease this to a 25, I'm sorry, that should be a 10. So my t value here should be 0. T value should be just negative 5, I believe. Right. Now, if I were to decrease this to 25, that will make this to be. Oh, I'm sorry. I made a terrible mistake here. So that was actually the same thing as saying 0.25. So now let's say I change this to 25. That'll be 2 over 5. And when you actually do this into the calculator, you get negative 2.5 over 2. So negative 1.75. No, negative 1.25, I believe. And so your t value overall has increased basically, or decreased in the negative manner, going down this way, further down this way. So that means that your p value should have decreased overall. For some reason, this is not working out as I wanted it to be. Your t value should be, let's see. Inverse t. Okay, so I think the best way to do it is just to use a test for this. So mean and the standard deviation here was 2. Sample size was that, and then when you press calculate, you get a sample. You get the p-value of 0.014. And if I were to do the same thing with a t-test, same with the data, but I changed my sample size to be 25. Oh, sorry. I get 0.22335. Okay, so my p-value has definitely increased. It got a lot larger from before. Now, in terms of the diagram, this, like, I wanted to demonstrate it to you guys that because I am looking for the values that are different, the proportions here, if your t-value stands at negative 0.25 and versus negative 1.25, since the t-value actually got larger in this case, in terms of just the magnitude, the p-value actually, well, let's just take a look at the calculator and see what happens. So first of all, if I do test, t-test, and if I were to draw this out, so that's type of the area that I'm going to get. Look at the shape, the t-value where it's at, negative 1.25 and 0.2234. And then if I were to do the same thing with now the size of, let's say, of 100, now it's actually further down the road there. So I think the t distribution, right, so the t distribution graph should actually, so this will actually give me negative 2.5 instead. I think I just completely miscalculated this one here. So let me just verify this real quick. So 7 minus 7.5 divided by the standard deviation of 2 divided by 5 here. No, that will give me, oh, sorry, that should be, so negative 0.5 divided by 2 over 10 because the sample size is 100. Right, so there we go. That makes a lot more sense now. Okay, so when you actually plug in 100 versus 25, the t values that you get is respectively is negative 2.5 and t value is negative 1.25. So for a while, I've been struggling because I wasn't able to do mental math here correctly. But in a sense, if negative 2.5 from 0 is all the way over here. So this is negative 2.5, positive 2.5, and these are the two areas here and there. And now if it's 1.25, negative 1.25 means it's closer to being this way. And so your two-tailed test, your blue area will significantly get a lot larger due to that reason. All right, so that was a little bit of a challenge, but I'm sorry about the math here, but I hope that that helps here. Number 37, we're on our last page. Based on the data above, which of the following will be true? We have a sample standard deviation. We have the sample mean. Let's put that into a test and see what our p-value is. Stat, test, t-test. We have everything. So we have the null hypothesis value of 14. The sample size here, I believe, was 16 bags, stated right here. Sample standard deviation is 0.24. Oh, I'm sorry. The mean is okay. So the mean is 13.88. Sample size is going to be 16 down here, and we want to look for that is less than 14. So calculate, and so the p-value I get is 0.0319. So when can I reject it and when can I not reject it? So we would reject H of O, the null hypothesis, if P is less than alpha. It is definitely less than 0.1, definitely less than 0.05, but not less than this. So it should be B for this one. 38, referring to the information above, suppose we are not sure the distribution of net weights was normal. Which of the following examples would it not be safe? They should have really bolded that word. It's really easy to overlook that. Which of the following will not be safe? The worst answer possible here. The mean and median of the data are nearly equal. That could mean that it's sort of normal shaped, I guess. Stem plot of the data is roughly bell shaped. I mean, that is the perfect answer. That's what you want to get if you want to perform the t-test, but it will say it would not be safe to do it. A stem plot of the display is a large outlier. I mean, that just clearly states it. Any large outlier, obvious skew, obvious outliers demonstrated, we do not want to use a t-test. Sample standard deviation is large, doesn't really have a huge impact on whether it will be safe or not. Histogram does display moderate skewness. Yes, that's something that you do not want to use, but C is much of a better answer to this question. And this one is really simple. I believe it's just going to be C. We're talking about difference, right? So we're talking about how it's not equal to 0. We want to eliminate D and E, obviously, and that should be it. For 39, the answer choice is indeed C. Okay, so with the exception of, I think, 36, I think most of it went pretty well. I'm hoping that this video, guys, please just watch it and make sure that you guys understand how to perform the t-test, what it is, difference between Z and t-test, when to find it, and just the formulas here. They're really just the same thing over and over again with a bunch of these new different symbols. On another video set, I will provide you guys with an explanation from question number 40 and beyond. We have several more multiple choice to do. And starting from 53, it's just going to be free response questions. And yeah, that's going to be it. Thank you guys so much. I'll see you in the next video.